of all, Spark SQL. So Spark SQL is actually a very recent feature added, in fact, in Spark 1.0, which isn't out yet. So you can get Spark SQL in master, but this is one of our most exciting developments over the last couple months. And what Spark SQL does is give you the capability to, first of all, leverage your what you've already defined in Hive, maybe. So let's say that you've you're using the Spark API to kind of parse text files, to split them by commas, to filter out rows, filter out data based on the fifth field being greater than 5, right? But then you might say, well, hey, I've already defined these data sets in Hive. Hive already understands the structure of that file, that it's a comma-separated file. I've already given each of those quote-unquote fields a name. Why can't I just point to my Hive metastore and then access the data using that metadata, maybe using a filter with a named column as opposed to the fourth field? So that's one of the ways that Spark SQL is very helpful, is because it can leverage your Hive metastore, use your same Hive SERDES, the same UDFs and whatnot, and give you access to the same data using basically HQL as well. So your HQL, your Hive query language code that you might have written before, should be completely compatible inside of Spark SQL. So that's very cool. In addition to having Hive compatibility, we've also added Parquet support. So Parquet is in case you're not familiar with it, is basically a data file format, a serialization format as well, where the data is stored in a columnar fashion, and then it includes metadata with it. So unlike the last example I described, where maybe you have a comma-separated text file and then you have to use the Hive metastore to tell you what the structure of that data is so you can come back and query it. If you're using something like Parquet, you actually have the metadata built into the file in the header. And so that's pretty advantageous if you